This is a one mark question asked in GATE 2020 of instrumentations. This is actually from three-phase networks. So generally if you go through the syllabus of instrumentations of network theory, three-phase network analysis is not given. So generally these kind of things are being covered in three-phase power measurement. Before three-phase power measurement, basics of three-phase networks are being covered as far as instrumentation branch is concerned. So you can treat it either the measurements or might be networks as well. It's up to you. The given question is three 400 ohm resistor are connected in delta and powered by a 400 volt RMS 50 Hz balanced symmetrical RYB sequence 3-phase 3-wire mains. The RMS value of line current in ampere is how much? Okay, this is the question. So basically this is the very idealistic case they have given. So we have the RYB sequence or positive sequence and it's a balanced symmetrical. So what this means that in the three-phase supply, so there are three individual sources, each of the magnitudes or the amplitude of sinusoids and frequency are same, they are just phase shifted with respect to each other by 120 degrees. So that is what the meaning of balanced and symmetrical. Okay. So what is the nature of the source, whether it is a star connected source or delta connected source, that is not given and that is not of interest as far as this question is concerned. So you can think of either star or delta, it's up to you. So I am not taking anything, so let's put it in a black box. So this is, the nature is, this is 400 volt RMS 50 Hz, okay, this is given. And let's say there are three terminals are coming out of this, R, Y and B. And what they are telling is, there are, there is a delta connected load and that to be each of this resistance value are how much they are given? 400 ohms. So each of these resistance value are 400 ohms. So I am connecting them, this RYB sequence, something like this, okay. And we are supposed to find RMS value of line currents, okay. So what is the meaning of line current? What is the meaning of phase currents? So generally this RYB, okay, these are the lines, okay. So if I ask you what is the current that is passing in this is the R line, I will say it's a line currents. What is the current passing in Y? This is the line current. So this is the line currents. So and what is phase currents? So if you concentrate the load segments, if I take what is the currents in each of the individual branches, okay, so those currents are known as the phase currents and the corresponding branch voltages are known as phase voltage. So phase voltage, phase currents, generally we take care about this in the load segment. So individual branch voltage and individual branch currents are known as the phase voltage and phase currents, okay. And line currents are the current that is passing through line, and line to line voltage or simply line voltage is the voltage between any two lines. So either RY or YB or any two line you take, the corresponding voltage between them we call it is the line voltage or line to line voltage. Both of the meanings are same. Actually this 400 volt which is given, this is actually the line voltage they have given. If some of you might have little basics of three phase, so this is actually the line voltage informations. So basically it can be any line you can take because magnitudes are same, and in this case we are nowhere concerned regarding the phase as far as this question is concerned. So only with respect to magnitude the we can easily solve these problems. So you can take any these things, any two line you can take. So for example I have taken RY, you can take YB, okay, or you can take BR, like this any line you can take. So and it's very obvious, like any magnitude of phase currents and this thing you find, magnitude will be same, only phase things that will vary, that we have to be careful, but magnitude is very straightforward. So this voltage is given 400 volts, alright, this is given 400 volts. So now we can see here, so if this is 400 volts, so this is between what I have taken for RY segment. So the voltage between this point and this point is 400 volts, okay. So obviously what is the current? 400 by 400, 400 volt is applied here to this 400 ohm resistance 400 ohm. So by Ohm's law, the magnitude of current in this branch or which is the phase currents, that is voltage by resistance, 400 by 400 becomes 1 ampere. So let's say this is the current directions. So this is the phase currents and this phase current will be 400 by 400, so this will be 1 ampere, okay. And in the delta networks, okay, or in the delta load, so this is a standard relations, proof is not we are interested in this case. So what happens is the line currents happens to be root 3 times of phase currents. Magnitude of line currents is root 3 times of magnitude of phase currents. So because here the phase currents magnitude I am getting it is 1. Don't forget I am just writing the magnitude. So if you want to be very strict sense, you should make use of these connotations. So phase we are not interested. Okay, so this will be root 3 into I phase magnitude is anyway 1. So this is root 3. And what is root 3 value? Obviously it is 1.73 ampere is these things. But is it in RMS form? Yes, it is in RMS form. How? Because this information is already in the RMS forms. So we have made use of information in RMS. So the obtained answer is also RMS. No need to again, go back into peak RMS and all. Okay. So this is the analysis. 1.73. Actually, I have explained it. So that's why I have taken around 4-5 minutes of time. But if some of you have little bit of basics, so just by look itself, we can tell the answer. It will be 1.73, not even 5-second job. Okay. Anyway, the answer of this question is 1.73 amperes.